Oh, just give me the lights, would you? So describe the transformation. Describe the transformation of the graph of the function from the graph of the parent function. So f of x on A, that's the child. Parents have children. What kind of parent does this child have? Would this child have a quadratic parent, a linear parent? Quadratic. What gives it a way that's quadratic, Gomez? Right, the exponent, second power. Remember, I only threw 4 parent functions that you're responsible in this section. Quadratic, linear, absolute value, and constant. So we already know just by that, that gives it away it's quadratic. Describe the transformation of the graph of the function from the graph. So what kind of transformation would it be? Well, last week we took these notes. Remember when we summarized the linear functions transformations here. We summarized the absolute values. It should be in your notes. We summarized the quadratic functions. All right? So let's see what's going on. We have something in parentheses. So I know it's this kind of case. It's going to be, right, since we have a plus some number, it's going to be a shift h units to the left. So coming back over here, notice the way the computer wrote it. Let me just type this and it has the answer here. So 2 units to the left. There it is. Something like that. 2 units to the left. Describe the transformation graph. So this would be a shift 2 units to the left. All right, for B. Well, before we go on to B, any questions on that? So I thought out loud. My thinking process was this. I looked at the function. I asked myself, self, what's the parent? Is it quadratic, absolute value, linear, or constant? Gomez got it. It was quadratic. Then I asked myself, self, what kind of transformation is involved? Just go to your notes. And we saw that it's a plus some number, so it's 2 units to the left. Someone besides Gomez, what parent family is B related to? G of x. Someone besides Gomez. What does the parent look like here? It's quadratic also. X is second power. So let me look at my quadratic transformation notes. Let's see. We have something in front of the x, a coefficient in front of the x. Let's see how big that coefficient is. Is a coefficient in front of the x greater than 1? Or is a coefficient of x greater than 0, less than 1? In other words, is it a fraction? So coming back over here, the coefficient is not a fraction, it's greater than 1. Hence, it's a vertical stretch by a factor of 2. Vertical stretch by a factor of 2. Okay? That's how you'd write it. You thought it was going to be what?
So the y is 2, just because 2 is a whole number in there, that's why everything is to do with 2.
Well, let me see if I'm understanding your question. You've noticed that in all 3 examples, the number 2 is involved. Okay? They're just doing that so you can see the differences in transformations.
So if 4 was there, it would still be 4.
Right. You can replace these with any number, it'd still be the same answers. Instead of vertical stretch by a factor of 2, it'd be a vertical stretch by a factor of 4. It'd be more skinnier because you're stretching it even more. The bigger the number, the skinnier that parabola is going to look. So, in other words, really? Really? Ah, I forgot to calibrate my puppy. Huh? Yeah. 1 second here. So Barry's question, really quick. Barry's question is, what if this was a 4 here? Instead of 2, you had 4 here. Well, it would be the same answers, but just wherever you see a 2, it'd just be 4. So it'd be 4 units to the left. Vertical stretch by a factor of 4. This one in particular, let me talk about. So we know that the parent function of f of x equals x squared looks like this. It goes through 0, 0 like that. That's the parent function. A vertical stretch of 4 would look like this. It would be skinnier. A vertical stretch of 5 would look even skinnier. We're stretching it more and more. Vertical factor of 6, and so on and so on. It gets skinnier and skinnier. We're stretching it more and more by that factor. Right? And I showed you that last week with Desmos, and we're gonna work more on that right now. After this day in history. Let me press play. Get the same note paper out that you put this stuff on, our summaries. This is just a continuation. We're not going to start a new session. I just want to go over some more examples. What if you don't what? Graph negative x squared and its parent function, then describe the transformation. Graph p of x equals negative x squared and its parent function, then describe the transformation. I'm going to write that down. So, yes, I am, exactly. So what I'm going to do, they're saying graph p of x equals negative x squared. What I'm going to do first is I'm going to graph the parent function. And once I have the parent function in my mind clearly, then I'm going to do the transformation here. Okay, so let's do the parent function first. I know the parent function is this. F of x equals x squared. Now, I'm hoping that you end up memorizing how the parent function looks. In other words, you should know by now that the parent function of a quadratic goes through 0, 0. And it kind of goes like this, right? But what are exactly some of these points? That's what I want to get into, and I want us to memorize them. So we know it goes through 0, 0 for sure. It goes through the origin. That's definitely one of the points. Another point on it would be, well, let's do a little table of values. Just to make sure, what about the other points of the parent function? If x is 1, what does y become? Let's see. So 1 to the second power is 1, huh? So f of x becomes 1. So look, I'm going to plot that point. 1, 1. Right now I'm doing the parent function. Here's your parent function. We know how it looks. We're just getting very detailed and specific with the points. How about if x is negative 1? Also 1, huh? Because again, negative 1 to the second power is negative 1 times negative 1. It's going to be positive 1. So look at that point. Right? Just for giggles, let me do another one. Leave me alone. If x is 2, what does y become? F of x. Remember, f of x means y. Y and f of x mean the same thing. So if x is 2, what's 2 to the second power? Is 4, huh? Talk to me. That means the coffee hasn't kicked in. Good looking now. Negative 1, 1. That's my secret. Don't tell anybody. All right, let's go 2, 4. 1, 2, 4. And negative 2, 4. Negative 2, 4. So here's my parent function in red. Coming down and coming up. Go ahead and do that with me. Go ahead and draw a nice parabola with me. That we have the parent function in place, we are now in a position to just do the transformation easily. Very easily. What kind of coefficient has been placed in this child? The parent had a child. What's the coefficient? Negative 1. Negative 1. So if I look at my notes on transformations, a negative coefficient is a reflection in the x-axis. So this axis right here, the x-axis, I'm going to flip the whole parabola over it. So every point here on the parent function will be exactly the same distance from the x-axis on the other side of the x-axis. So this point is one unit away from the x-axis, so the new point here would be this one. Origin stays there. This point is 1 unit away, so this one's going to be 1 unit away. This coordinate right here is -2, 4. That's 4 units away, so I'm going to put 4 units away at the bottom. 1, 2, 3, 4. See, I'm flipping everything. 1, 2, 3, 4. So 1, 2, 3, 4. Here's P of x. Here's the child. This is your function. This is the transformed function. So I took every point from the parent function and just reflected it. I flipped it over the x-axis. That's a reflection. Let me get my graph paper. What is up with my gizmo? All right, here we go. All right, so g of x, is it x plus 2 or x plus 3? All right, here we go. There's the child. I first asked myself, what does a parent look like for this child? What family is it related to? Constant. Close. It's linear because it has x to the first power. It's linear. So for linear, let's first graph the parent. I'll do it in red. The parent is f of x equals x. So that would be right here, 0, 0. If you ever forget and you don't have your notes in front of you, just do a simple table of values. Right? 0, 0. 1, 1. 2, 2. Whatever x is, y is going to be, right? -1, -1, and so on. There's my parent function. In red. Now we're going to do g of x in blue. So looking at my transformation notes, this is going to be a horizontal or vertical shift here. Is it a left to right shift or up and down shift? Up 3. It's not in parentheses, so it's vertical. And it's positive 3, so it's going to be up 3. So every point on this parent function, I'm moving up 3 points. Look at 1, 2, 3. Every point I graph. 1, 2, 3. 1, 2, 3, and so on. So here's g of x in blue. So we got the parent and we got the child. H of x equals x minus 2 squared. Let's graph the parent and let's graph the child. It is. So there's my parent in black. 0, 0, 1, 1, 2, 4, 0, 0, -1, positive 1, -2, positive 4. Now, horizontal or vertical shift, Brian Gomez. Horizontal or vertical shift here, what do you say? Vertical, thank you. Ms. Sanchez, horizontal or vertical shift? Vertical shift, thank you. Ms. Martinez, horizontal or vertical shift? Vertical, thank you. Beltran, horizontal or vertical shift? Thank you. Let's see, Valtierra, horizontal or vertical shift? So everyone's saying vertical. Carrillo, what do you think? Horizontal or vertical shift? X minus 2 in parentheses. Vertical. It's horizontal. When you have the parentheses, that gives it away it's horizontal. And remember, we go the opposite way. If it's a minus, it goes to the right. If it's a plus, it goes to the left. So this is a horizontal shift to the right 2 units. Gentleman in the back, let me have the floor. Thank you. So every point here, I'm going to go 2 to the right. So the vertex goes 2 to the right. This point goes 2 to the right. This one is here. Everything's 2 to the right. Every point I graphed. And now the child is in blue here. There's your child. Value of x. I'm going to write that down. Obviously opposite value? Absolutely. N of x equals negative absolute value of x. So, coming over here. So n of x, some function named n of x equals negative absolute value of x. Let's do parent function first. The parent of absolute value is f of x equals absolute value of x. So 0, 0 is definitely 1. Remember, this is the v one, the one that looks like a v. It's in our notes. 1, 1, negative 1, 1, negative 2, 2, and so on. So here's the parent function, absolute value. All right? So what kind of transformation would this one be? Anybody? Horizontal shift, vertical stretch, vertical shrink, reflection, it's a negative coefficient. We're going to reflect it just like we did on example 1, I believe. So here we go. Every point, I just ask myself how far away is it from the x-axis, and I flip it over the x-axis. So this point is 1 away from the x-axis, so the new point would be right here. 0, 0 stays the same. This is 2 units away from the x-axis, so the new point here would be 2 units away, and so on. And so here's our child in blue.